Our next section of lessons focuses on friction. Since energy is so important to transportation, let's use our energy and matter cross-cutting concept to help us figure out even more insight into what's going on. Whenever we see energy, we can ask 3 questions. Where did the energy come from? Where does it go next? And does it change forms along the way? We have a convenient graphic organizer to help us think about that, an energy source receiver diagram. Now, all vehicles take energy from some source and change it into the energy of motion. Here's what that would look like for an electric car. We start with a battery's electrical energy. But then when we ask the question, where does the energy go next? There are multiple destinations. Some of the energy transfers to the road in the process that we call friction. Friction can be thought of as an energy thief, or as a force. While the wheels work to push the car forward, friction is a force that pulls it back. But this energy view and the force view are very closely related because every force requires a transfer of energy. So as you launch into the drag racer section with your students, be ready to think about friction in both of these views, force and energy. We're eventually going to be looking at the forces that speed up and slow down drag racers, but to set up that challenge, we'll first look at 2 other vehicles. We learned that kinetic energy depends upon speed and mass both. But now we have this phenomenon where we have a bulldozer which weighs less and it moves slower than a bus. So you'd think that it would take less energy to move, but in fact it takes a lot more. Why? Well, from this we can discover the concept of friction. We start lesson 10 discussing our bulldozer and bus phenomenon. Then we introduce the drag racers. We're going to build a super simple drag racer. We're going to build super simple drag racers that allow us to visualize the forces acting on them. There's a string connected to a weight that we drop over the edge of the table, and it pulls the drag racer along. The student's job is to create a drag racer that goes faster than this simple example. A handout lays out all the criteria and constraints of this design challenge, and then students are going to build and test their models. We begin lesson 5.11 discussing the forces on the drag racer. They answer some simple questions to start with and then get to more challenging questions as they start to realize that there are a whole lot of forces at work, and it's the sum of the forces that determine the movement. And one of those most important forces is friction. Then students reflect on the design of their car and how they can modify it to reduce friction even more. They redesign it and test their cars more. Students are going to consider what happens if they add weight to their race car. How will that affect the forces? And we define acceleration and explore how it's related to the forces acting on the object and that object's mass. As an exit ticket, students return to the phenomenon of the drag racer and draw out the forces acting on it as it accelerates. In our next unit, we switch from drag racers to bicycles.